Welcome to Elector News Bites, our show dedicated to updates from the world of electronics and semiconductors. I'm your host, Stuart Cording, the electronics reporter. In this month's show, I'll be discussing a free for makers version of Flowcode with Matrix Technology Solutions, finding out how to quickly get to grips with IoT, exploring a net zero electric vehicle charger, expanding I/Os for microcontroller applications, and reviewing the launch of a new automotive capacitor. However, if you're in a hurry, use the description below this video or podcast to jump straight to the topics that are of interest to you. Otherwise, let's get started. If you're struggling to get your IoT project off the ground, you might like to stop by Hardware Pioneers Max 2023. With more than 75 exhibitors and expecting over 2,000 visitors, this annual event takes place on the 23rd of July in London, UK. The show brings together trailblazers in electronics and IoT with representatives from the semiconductor industry, wireless module manufacturers, and connectivity experts. Visitors can also expect more than 20 hours of talks, panel discussions and seminars, and there will be plenty of time to chat with other visitors in the networking sessions. You'll also have the chance to hear Massimo Banzi, the visionary co-founder and CEO, explain how Arduino is enabling rapid innovation in manufacturing. The ongoing frustration for electric vehicle users is the lack of charging stations. XCharge, a leading high-power smart charging solution provider, could change this. Their Net Zero series of chargers contain 233 kWh battery storage, which is expandable to 466 kWh. This reduces the input demand between 30 and 60 kilowatts, making the Net Zero series much easier to install than traditional EV chargers. By leveraging peak shaving, the inbuilt battery can be charged during periods of low energy demand, then deliver it during peak times. The units are aimed at charge point operators, parking providers, and fleet managers, to name but a few. Increasingly, robots are proving themselves to be an affordable approach to improving automation and efficiency. To help those looking to make a start, Distrelec has just launched the second part of their Guide to Robotics and Automation. Having previously covered the background of robotics, their evolution, and how they are built, this guide focuses on network connectivity and integration in certain workflows. It covers case studies in logistics, looks at their impact on agriculture, and offers advice on connectors and suitable wireless technologies. There is also a chapter on low-cost, compact robot arms that are well suited to collaborative or cobot deployments. The guides are available now on the Distrelec website. This episode is sponsored by Eurocircuits, a leading European manufacturer of PCB prototypes and small series production. They specialise in fast and cost-effective production and assembly and excellent on-time delivery. With simple online ordering and virtual manufacturing capability, designs can be reviewed before ordering to deliver on time and within budget. The Eurocircuits Group, founded in 1991 and based in Belgium, employs more than 500 people and manufactures in two modern plants in Hungary and Germany that conform to Europe's high sustainability standards. To learn more, just follow the link in the description accompanying this episode. One of the major challenges for dairy farmers is weed control in grasslands. Tackling this is German startup Pultec. They're the winners of Avnet Silica's Bay Startup Robotics and Adaptive Computing Challenge, a competition run in collaboration with AMD. Over 12 weeks, early-stage startups in AI-enabled robotics received help with concept validation and product development from industry professionals. Teams also had access to free starter kits and the AMD Kria App Store. Paltec's solution is based upon the Kria KR260 and a custom shield that includes GPS, inertial sensors, CAN bus communication and data logging. Their approach coupled ground-based robots with drones for accurate weed detection and optimal path calculation. Upon reaching a waypoint, weeds are removed mechanically, avoiding the need for chemical weed killers. Sourcing a microcontroller with enough I/Os often forces designers to select a device that is unnecessarily expensive. To combat this, engineers can use GPIO expanders to add the necessary signals. Nexperia has just launched the new NCA95XX family of I2C devices for exactly this purpose. Operating over the 1.65 to 5.5 volt range, these chips add 16 I/Os capable of directly driving LEDs. 400 kHz fast mode operation is supported, enabling low latency control and response, and the family also provides an active low interrupt signal. A speciality of the NCA9595 is the configurable internal pull-up resistors, helping to reduce the component count on input pins. To get started, the team has also created an Arduino Shield, accompanied by ready-to-use software libraries. When it comes to monitoring temperature, PTC thermistors are a low-cost, easy-to-deploy technology. To further simplify their integration into your circuit, Toshiba has launched the ThermoFlagger range of temperature monitors. The device uses a current source to monitor a string of PTC thermistors. Should one device hit a specified temperature, the ThermoFlagger outputs a signal. The family consists of two devices, the TCTH021BE, which provides a non-latching pin, while the TCTH022BE's output is latching. Both devices are offered in a small 5-pin SOT553 package, operate from a 1.7 to 5.5 volt supply, and are available now. When small value capacitances are needed, multi-layer ceramic capacitors, or MLCCs, are a great choice. As a result, demand for them in automotive applications is expanding rapidly as the number of electronic systems grows. To meet this need, Samsung has launched what they claim is a breakthrough in MLCC technology. Their latest 10 microfarad component measures just 3.2 by 2.5 millimeters and has a voltage rating of 100 volts. The new capacitor is the result of Samsung's proprietary material atomization and ultra-precision lamination capabilities. They expect this miniature high-capacitance device to find a home in autonomous driving vehicles, driver assistance systems, and lighting applications. If you'd like to evaluate this new capacitor, samples are available upon request. Gallium nitride devices, also known as GaN, offer incredible benefits to power conversion applications, but deployment can be hindered by the high voltages used. This challenge has been tackled by Bern University of Applied Sciences in cooperation with InnoScience. The team deployed 650 volt InnoGaN HEMT devices in a multi-level topology to implement an 11 kilowatt 850 volt converter. The research resulted in a 3-level active neutral point clamped converter reference design that avoids the use of snubber capacitors or expensive silicon carbide diodes. Using just 6 GaN HEMTs, the design was able to reduce the size of the filter and the overall design, thanks to the high switching frequency used. This reference design could form the basis of converters targeting a range of industrial applications, motor drivers, or even solar inverters. Software gets a healthy dose of focus thanks to apps, ChatGPT and Minecraft. And while Arduino and Raspberry Pi have helped, circuit building often reverts to connecting shields with modules. Tackling this is Jen Fox with her new book, Beginning Breadboarding. With it, she hopes to bring more prominence to the hardware that makes software possible. Breadboarding was selected as it is easy and safe to use while also being affordable. And if you mess something up, you can pull out a few wires and start again. The book is also suitable for educators going beyond the scope of the middle school Next Generation Science curriculum. Jen told me she's taught breadboarding to children as young as 9, to their grandparents and everyone in between. Beginning Breadboarding is available now both in print and as an ebook. While scrolling through LinkedIn or chatting with peers, it won't be long before someone highlights the lack of talent entering the electronics and semiconductor industry. But it isn't due to a lack of resources. I spoke to John Dobson and Ben Rowland of Matrix Technology Solutions to learn how they've been supporting educators, students, makers and industrial customers for decades. I started by asking John how Matrix helps educators make electronics accessible to students.
Matrix as a company has a wide portfolio of solutions for learning electricity and electronics. And we start with a product called Loptronics, which is a baseboard with about 35 metal pillars on. And to these conducting metal pillars, you add a variety of electronic components like switches, bulbs, transistors and resistors, and you kind of build circuits. As you build the circuit, you can see the circuit diagram. Understanding circuit diagrams is a key learning outcome. And this series of products covers the very basic fundamentals of electronics and goes through to relatively complex circuits like Class A, B amplifiers, timers, and things like that. So from say the age of 14 right through to undergraduate level electronics. And in general, our philosophy is that for educators, we provide hardware, we provide software, and we provide the curriculum that allows educators to deliver really high quality courses in engineering, in particular electronics.
Now, surface mount components, for example, aren't the best starting point for students learning to solder. How do you make such devices more accessible?
Well, like a lot of companies, we've moved to modules. So this is a circuit board from our eBlocks 2 range of products. And the microcontroller is a small surface mount microcontroller you can see there. So like many other companies, what we've done is taken those surface mount parts and packaged them on a circuit board. But also we've gone a step further than many companies, and we have all the ports available on these lovely multi-way connectors. So the multi-way connectors include, in this case, 8 bits for port B, but also power and ground as well. So the idea is you just plug on, in this case, an LCD display. In that case, is that a Bluetooth module?
Yeah.
So you can see that with these eBlocks ports and all the add-on boards, and there's about 20 or 30 of these add-on boards, then you can really quickly make a electronic system. And the idea for education is to provide motivation for students. You make things easy and you provide blocks of technology which allows them to go further, faster.
You also make entry into the world of microcontrollers easier by circumventing obtuse C compiler error messages with your design software Flowcode. Can you explain what students experience when they get started?
When you start a Flowcode project, you pick a microcontroller device from a list of hundreds of different devices. You are allowed to choose between an Arduino, a PIC device, an ARM, a Raspberry Pi, an ESP32. So there's a huge wealth of chips available. Each component has a library of functions, and we've developed these functions to be as simple to use as possible and straightforward. Each function can be dragged on. It has a tooltip. If there's any parameters or returns, then we describe what those are with tooltips. We try and make the experience as simple as possible.
I've also heard that Flowcode version 10 has just been released. What's new in this version?
So it's free for makers. Previously, we charged for all versions of Flowcode, but now this version 10, of course, we're feeling pressure from people like Arduino, and so version 10 is fully free for makers. We charge industrial customers and we charge educational institutions, and that's how we make our money to support the development. But we've made Flowcode free for all those hobbyists that want to get involved in the world of electronics.
Version 10, we've added the ability to have several panels where you keep your components. In the past, we've had an OpenGL engine that allowed us to have a 2D panel and a 3D panel, and that allowed us to have 3D components, things like motors, things like CNC machine simulations, so you can simulate the whole system. Now we've still got the OpenGL panels, but we've now also got 2D, proper 2D panels, so that you can create proper nice looking UIs. So we have a feature called App Developer, and that allows you to create a Windows application. So you can do things like create an embedded program. You can download this to some hardware. You can then have an app developer program that talks to that hardware, and you can roll that out to customers.
You're also tackling digital communications, a topic often heavy on theory and light on practice. What's the new product you're introducing to support this?
This is what we're calling SysBlocks, and a SysBlock is basically a kind of analog signal processing system. And I've got 3 of them on this panel, and this panel is all about studying communications. And a SysBlock is basically a very powerful microcontroller. In this case, it's a PIC32 from Microchip. And on this panel, we've got 2 inputs and we've got 2 outputs, which are on these small BNC connectors. And between the 2, we've got a single chip microcontroller running at something like 200 megahertz. It's got some A to D inputs and it's got an A to D output. Here you can see a panel where we've got 3 SysBlocks. The first one is the modulator or encoder. The second one provides noise. We then mix those 2 together in a small analog mixing board. And then this last SysBlock is a demodulator decoder. And together, this particular SysBlocks panel allows students to learn all about digital communications and software-defined radio. So you can put an AM signal in it and you can demodulate it, or you can do FM. You can study things like QPSK, all the different types of encoding. You can look at bit error rates, signals and noise ratios. You can look at spread spectrum and correlation. And it's a platform we've developed for the teaching of communications.
That was John Dobson and Ben Rowland of Matrix Technology Solutions, sharing the new free version of Flowcode 10 for makers and introducing their SysBlocks pseudo-analog development boards. And if you'd like to try out Flowcode, just visit www.flowcode.co.uk. So that wraps it up for this month's episode of News Bites. If you'd like to learn more about the technologies highlighted, check out the accompanying description and links. Should you have a news update you'd like to share, please drop me a line to tell me more. You'll find my contact details on the Elector website, or if you prefer, connect with me, Stuart Cording, on LinkedIn or follow me on Twitter. While you're here, please subscribe to Elector TV Industry on YouTube, or give us a rating on whatever podcast platform you're listening to us on. Thanks for joining, and hopefully we'll see you on Elector News Bites next time.